think about UHD again. Think about UHD and the number of enabled devices, enabled screens. It's a big voice. That we're shipping today is over 32 million that we were shipping 2 years ago, and that number is growing steadily. You know, manufacturers are pushing out in the market. There's still hardly any channels really compared to the thousands of channels that we have out there in HD. There's only 90 channels. Last year in 2016, they're UHD to date. Again, you know, we want to stream more, we want to be more mobile, we want to have higher qualities and more. I mean, I'm not even going to go into VR, AR. I'm part of a panel session tomorrow talking about it. You know, again, it's another consumption medium, it's another potential vehicle for entertainment. You know, we will see how fast and whether it will replace. Will accompany today's entertainment. So the point I wanted to make is that yes, there is a need, that there is a willingness to push consumption and new ways of consumption, and convenient consumptions of higher quality content. And you know, but today we're not quite there yet. There is still elements that are required to unlock that consumption. And I think technology is one of them, and particularly. Close to us and key to us is really to see what the technology compression market can do to enable those services, right? We know, and the technology and compression market is actually more in flux than ever. I think there's a big spotlight, you know, in the last 2 years on compression technologies, which we welcome, and a lot of uncertainty, maybe.
Yeah. Well, you know, it's clearing out, I would say.
Okay.
And specifically. We see that there is hype, there are things that didn't happen as much as we were thinking, but there's one thing for certain. People want more quality video, and there are some bottlenecks today. Codecs, of course, are a way to solve this problem, and we're talking a lot about what's the next generation, because one thing seems for certain is that H.264, FX4, is not going to be able to solve the needs that Javier was talking about. And if we look at alternatives, we've been talking a lot about alternatives and next generation codecs for years, but I think that the distinctive factor of 2017 is that now the alternatives for the next few years are pretty clear. Essentially, we have had H.264 dominating for over 10 years now. We are used to a pattern that has been true for a few decades now, 2-3 decades, where every 5 to 10 years we see a step change improvement by a little bit at the expense of replacing all the hardware ecosystem because of the much higher processing power requirements of the next generation codec. HEVC is the representation of this approach. So we know that the first alternative for next generation codec is HEVC, and HEVC of course is a strong candidate. It comes from the usual standardization process. But it's not getting traction for known problems. Known problems being, yes, the licensing problems, but people are not talking that much about the practical problems and practical limitations, which are essentially in terms of processing power requirements, which are pretty big, especially if we talk about Ultra HD, how many nuclear power plants do we need, and all those things, costs, and does it really solve the problem? But essentially, that's one of the alternatives. Then we have the open source alternative. Essentially, people and customers of codecs and operators, especially in the OTT space, that joined up with Google to say, well, let's try to find a royalty-free alternative that kind of performs as well or better than traditional codecs. And VT9 was the first iteration. We will see a next iteration with AV1 when it comes out, and definitely in the next 3-5 years, that will be one of the options. And we've seen also at this show what it entails, like 300 plus cores of processing for one HD stream, and we will talk about that. And then there is again the question: does it solve the problem or not? And then there is us. There's Persys. Of course, in all these formidable alternatives, a much smaller company, but also it has its advantages in terms of responsiveness to customers, etc. And it has certain distinctive features. Distinctive features that we will talk about and just got better. But essentially, it's important to recognize that in terms of next generation codecs, this is what it will be. And will it be a winner-take-all market? Will it be a war of codecs? I don't believe so. Because what changed versus the past is that we're going towards a software world, so it's becoming much more similar to other things where there is competition. Competition means a single decoder, a single encoder in the future will be able to do maybe all of these alternatives. So it'll be a matter of what sorts out the problems that an operator has at any given time, not about there will be only one of these. What's very important is that there are two real-world problems that need to be solved, because the reality is, why on earth should we go to a next-generation codec? It's so convenient to use the H.264. It's been like that for over 10 years. Only for two reasons that can be found. One is actually the attention of everybody, which is compression performance and visual quality, correctly very important. But the second is as important, and I would like to stress a lot in what we will show you today, is computational performance. Computational performance is very often neglected, but aside from having a direct impact on compression performance, it has a phenomenal impact on monetization, costs, ability to deploy live, mobile devices, battery consumption, all the compatibility with existing devices, all of the things that ultimately you need to monetize a service that is not just for 2 or 3 early adopters, but is actually a mass adoption service. So, what problems are we solving today? If we look at distribution, because as I said, if we need to implement the next generation codec, we need to solve an actual problem. What Fabio was saying when he said, we would like to have OTT and other types of distribution to take over the world, but in reality, this is not happening. We would like to have Ultra HD mass distribution, it's not happening. Why is that the case? Because there are capacity constraints that are not defined and predicated in terms of a percentage benefits in compression versus the traditional legacy performances, but it's actually the capacity of existing data networks. And we've been working a lot with our customers in the past 2 years to figure out precisely with analytics what is really necessary in order to deploy at scale. And again, at scale I mean billions of people, not a few early adopters. If we want mobile video, for instance, so at one end of the spectrum, we do need to cater to the fact that 4G, 5G is more of the dream, and it'll be true maybe 10 years from now at large deployment scale. For now, we have 4G, but in reality, we have 3G and 2G. Actually, I would invite you later to look at the connectivity that you have here in Vegas, because very often I found myself in Edge. And this is frequent also in London, it's frequent also in other prime locations. And when I'm lucky here in Vegas, I'm in 3G. I'm on 3G. Yes, 4G is nice, but the reality of Edge and 3G, which happens still for more than 50% of the time, not 50% of the customers, 100% of the customers, 50% of the time between 3G and 2G. This means Edge connectivity less than 144 kilobits. And so in order to deliver video to people, you need to stay at 100 kilobits. And in order to deliver video to people in 3G, you need to stay below 300 kilobits or equal to 300 kilobits. These are practical constraints. And I was very happy to see that also Netflix published them, because they probably look at the same numbers and figures. So if we want to crack mobile video distribution, which is what millennials want, what a lot of operators want, these are the numbers that we need to cater to. At the other end of the spectrum, I don't want to go through all of the data networks, but Ultra HD is the other end, supreme quality, maybe in the future 8K, 16K. Then it's a problem of monetization. With cable satellite, yes, we can even put 30 megabits for a channel, or even 35, or even 50 if we want. But the problem is, will people pay for that? Will monetization work? In reality, we worked a lot. You might have seen the announcements with Tycom, but we did it also with other operators. In order to make monetization feasible for Ultra HD, whether you go satellite, cable, or fiber, you need to stay well below 15 megabits, and if possible, below 10 megabits. And otherwise, it just doesn't work. Numbers just don't add up. So we need to be able to do UHD films, so P24 type performances below 6 megabits, if possible below 4. And UHD high frame rate sport live delivery below 10 megabits. These are real needs, and either we solve these needs or mass adoption just doesn't happen in the next 5-10 years, because we already know the investments that telco operators are going to put in data networks, and despite the fact that some people think that magically the problem will solve itself, it won't. In the next 5-10 years, these are the numbers that we are seeing, and we check that in terms of telco operators and real-world cases. As a consequence, in response to these operations, these operating points, and other constraints, we showed the real power of being a flexible and responsive company and the real power of software. And so here at NAB, we are presenting Perseus 2. Perseus 2 is the response of Vinnova to over 2 years of real deployments, tests, pilots, feedback from customers, understanding the real needs and operating points that are necessary. And in response to this, showing how fast innovation can work when you are in software, when you don't need hardware acceleration that is dedicated, so 5-10 year cycles, we actually show step change improvement after just 2 years from launch. What does it do? Perseus 2 essentially does 3 things. The first one is more quality. More quality in those operating points that I was mentioning. So specifically targeted, not just to say it's X% better than before or it's X% better than the benchmark that you don't even know what it is. But I'm a fan of automotive industry where you don't say that you consume 50% less than another car that you don't know what it is, but you say how many miles per gallon you do. And so it's a matter of doing live sports video at 100 kilobits, for instance. More quality to us means exactly this. And so, just before you go there, I would go here, this here, and I would invite you to look at it later. This is something that I consider unprecedented, because you know that we already deployed fast films in India at 100 kilobits. We delivered video before, but this is actually a live sports feed at 100 kilobits. It's even 720p, half frame rate, but it's 720p. You might argue not a phenomenal quality 720p, but it's enjoyable. It's 100 kilobits. It can be received every time you can place a phone. And this is massive because it means real quality, not just for developing countries, but for developed countries, also for people that pay money. And it is compatible with every existing device, every phone call, every phone device, every tablet, everything that has a screen can receive this and can decode it. By the way, consuming less processing power. Then, also here, maybe you can see this a little bit better. You see an enlargement of the other operating point, which is an important operating point. 300 kilobits is actually what we aim at having most of the time, because of course we hope that that is just a fallback for a developed country. And you see what it was before. This is not something where you can deliver a service. This is something where you can deliver a service, even a monetizable service. 300 kilobits is especially important also because very often we tend to talk about bit rates, only think about the last mile, but people forget about the backbones. And people are finding out now with events such as the Super Bowl or cricket in India or other streaming events that you start having millions of people streaming at the same time. This is unicast. You get very often to several terabits of data. CDNs, backbones can do it. If you want to upgrade a backbone, it's hundreds of millions of dollars. So people are like, ooh, how can I do that? Like this. Because if you had 300 kilobits and a fallback at 100 kilobits, essentially you're reducing by about an order of magnitude the peak traffic in the CDN and backbone, which means you can serve 10 times more people with the same capacity in the backbone that you had before. So this is not just real money, it's actually the ability to perform a service. Then the other thing that Perseus 2 does is more savings. And I'm super passionate about this because people forget about processing power so much, because we were trained after decades of standards that were not considering processing power part of the equation, but just the video quality, because some hardware engineer will sort it out in hardware. And in my past, I was a hardware engineer for Intel, so I was feeling the pain for that. More servers means essentially doing better compression with less processing power. And Perseus 2 is even less processing power than Perseus. Perseus was already compatible with existing hardware. With Perseus 2, it made this compatibility even stronger, lowering even more the processing power required to do things. This means essentially that the same box, when enabled with Perseus, can do many more channels, and I mean also live channels, not just VOD, than before, which means if you take a box from an encoder vendor, you run it with H.264 native, you obtain X channels. With Perseus, you can get maybe twice the amount of channels with the same box. If you are, for instance, in an OTT ADR delivery context. And then, of course, you have lower unit cost of bandwidth. I like to talk about unit cost because it's not so important the total cost, because in reality, Perseus increases bandwidth costs because people use it more. And people want that because you're offering a service because you want people to use it. But it's important that the cost per minute of delivery goes down very, very significantly, and so the cost of storage. This translates, and again, I have a little prop. This is a prototype, and of course it looks big because it's a prototype, but in reality, this thing here shows that there is a live Ultra HD feed that, aside from compression, let's forget about the bitrate. Yes, it's 10 megabits for an Ultra HD frame rate at very high quality. But this means that a single live Ultra HD full frame rate channel can be done with less than $1,000 of cost. And in reality, this is a big thing, but it's an Area 10 chip. You can put it in a device the size of, it can fit in this briefcase that Alan has here. So this means server space, it means cost, it means electricity. It's actually, yes, it doesn't include our licenses, but I can guarantee that our licenses are not going to be material. And the comparison versus using 300 or 600 cores.
That's a mock-up for Perseus 2 right there?
Yes. And no, it's not a mock-up, but it's actually a live demo. Then we connect it there and we run a live demo. It will be soon in actual products, so in actual encoders, soon meaning in 2 months. We have the first encoder shipping. Yeah, because then you have cards that just fit into existing encoders and off you go, and you're able to do an Ultra HD with a very, very, very low cost device. And then this is another prop, which is not a prop. This is already in operation. And we're shipping many of these in the next weeks. This is our contribution server. This is standard telco equipment, $3,000, non-negotiated price for a server. We don't care, we don't do it. People can buy it themselves in the one. With this, with Perseus 2, you can do 8 visually lossless HD feeds and 2 visually lossless Ultra HD feeds. This is unprecedented savings, unprecedented power consumption, unprecedented server space. With this, you can do a remote production of 8 cameras, and you can fit it in 150 megabits in that case for visually lossless inter-only remote production. It's really cost. And this is something that I would like to stress, and I stress it so much because when talking about next generation codecs, it's very easily forgotten what it means processing power. And this means cost, and at the decoding end, it means running on all existing devices, it means consuming less battery power, it means being able to run with CPU, with GPU, with scripting, with JavaScript, with whatever you want. The consequence is also more platform support, because the consequence of this increased efficiency of performance means also it's even easier than before to be supported by your platforms. And in terms of platforms, of course, we mean encoders, we mean media players, and we mean also end-to-end systems, OBTs, etc. So for encoders, for instance, just some that I would like to mention, imagine we'll integrate Perseus 2 in the coming weeks. So as part of the Open Xenium platform, it will be available very soon, a Perseus 2 commercial implementation that will be deployed in Tier 1 operators. This is very critical to us. Imagine is a super strong partner because, first of all, they understood before others software-defined networks and open environments were different tools in a toolbox like a codec can be integrated very easily. Secondly, they are very important to us for our move towards the US very soon because, as you know, Imagine covers 100% of the cable operators in the US. And the cable operators in the US have MPEG-4 set-top boxes. And guess which one is the only next generation codec that can run on MPEG-4 set-top boxes. So, of course, we are very keen on our relationship with Imagine, and we're very happy that they were the first to start integrating Persis 2 in their encoders. Also, very important to us is the partnership with Microsoft, and Microsoft Azure will follow suit immediately in terms of availability on the cloud of Persis 2. This means both availability at encoding and availability in the Microsoft MFT libraries of all Windows devices. So essentially, delivering from the cloud Persis streams will be essentially a matter of a few clicks. And also very important to people, FFmpeg, we know, is an excellent environment to create flexible workflows. And several of our customers are integrating Persis in FFmpeg-based workflows. So it's also very, very easy now to leverage Persis in that context. And then many, many others. But I will mention another one which is used with Persis 2 and extremely important. A lot of people were talking about browsers where people don't want plug-in. And so very soon, meaning a few weeks, will be available an HTML5 implementation with scripted decoding for Persis. So also browsers will be able to very easily receive Persis streams. And then, of course, all the known ones, Android, iOS support, Exoplayer version, Visual On to cover all mobile devices with these implementations, and chipsets of set-top boxes for Broadcom and STMicro. Two words on what's under the hood. Persis 2 essentially does a number of things to achieve the efficiencies that we discussed. And in particular, it does things in the two versions of Persis that many people have come to appreciate. Essentially, one of the characteristics of Persis that are more distinctive is actually that Persis works in a multi-scale hierarchical fashion. And there are two ways to use that. One that we use in professional environments and production contribution environments, which is Persis Pro. The entire format is Persis wrapped in a transport stream compatible with standards, an MPEG transport stream, or an MXF for nonlinear workflows. In Persis Pro, the novelties are especially related to speed, guaranteeing the efficiencies that you've seen here. So essentially a massive cut in the cost per channel of encoding. We couldn't do much more in terms of losses and visually lossless performance because already Persis 1 was very close to channel limits. So also Persis 2 is a little bit closer to channel limits, but it doesn't make that much of a difference. The important thing is getting there quicker, and at lowest cost possible. So the novelty here is being able to run even faster on any device. On Persis Plus, is our version for distribution where Persis works in combination with other standards, with other formats. And the version that we've used for the past 2 years in this case is Persis Plus H.264. But today we're also announcing and presenting and showing that Persis Plus now works in combination also with other codecs like the GVC, DP9, in the future also AV1 when it'll be available. Persis Plus has very distinctive advantages because by using another codec format as well as the Persis format, it also leverages all the ecosystem compatibility of the base codec. Because, for instance, using Persis Plus H.264, we have the beauty of having, for all practical purposes, an H.264 stream, which means that for origin servers, transmuxers, encryption, CDNs, you name it, nothing changes because they receive exactly what they were used to. So this is essentially using MPEG. It is an MPEG stream. But it also uses the Persis elementary stream in order to achieve greater compression. To show what we did here, because here, of course, we worked a lot also in terms of visual quality and compression, because here we couldn't do much, but here we could. And so the new version is implementing a number of features. If you're interested, we can go in more detail, but just to have a very quick run through that. First of all, the temporal enhancement is much more efficient than before. So Perseus 2 does it much better, which means even stronger compression in certain use cases. We implemented also something that is quite known to MPEG formats, and we weren't doing in Perseus 1, which is psychovisual optimizations, which actually allow for even better use of the bitrate. Perseus 1 was a little bit more blind, still very efficient. Despite that, Perseus 2 is a little bit more intelligent in allocating the bitrate, which actually translates in even further visual quality benefits. And then a truly dissectable hierarchy, which means we can choose with much more flexibility than before the resolution of the base codec implementation, which actually means going back to this phenomenal 100 kilobits live sports. In this case, the reason why we can do this magic is that we can lower the overhead of MPEG quite massively by using a very low resolution base codec, which actually means low overhead, gaining 10, 20 kilobits, which at these bit rates mean essentially gaining a huge amount of bit rate to allocate to information. And of course it means flexibility, and I touched something that we should not have touched, but yeah. And then, as I mentioned, also the enhanced support of all codecs. So the fact that Perseus Plus now works also in combination with other codecs as well, HEVC, BP9. So essentially, when I mentioned that there are several alternatives in terms of next generation codec, in reality, I wasn't saying the entire truth, because Perseus can actually work in combination with them. It's not strictly an alternative. So if people want and can use HEVC, for instance, or BP9, because their decoders are new and can support the new standard, they can get the compression benefit of HEVC or BP9 in combination with Perseus. And the important thing, as I mentioned, is that this is not just theory, it's not prototypes, it's actually something that we are deploying as of these weeks. And so it is really ready to deploy. And this is, again, a demonstration of the power of software and the power of being compatible. The first deployment tool I showed already, this is P-Link, the new version. It's already out, it's already being used, and you will see quite a few announcements in the next weeks of use cases in remote production, in contribution, in backhauling, in Ultra HD that will leverage it. The important thing is that this machine, thanks to Perseus, can also be used in combination with cloud decoding, because Perseus is a software, can work on this guy, but can also work on anything that is on the cloud. So you don't need specialized equipment. You can work on an AWS or an Azure, and essentially design workflows and contribution systems that are quite effective and potentially in OpEx model, not just in CapEx model. And then, as I mentioned, extremely important to deploy at scale, the Open Xenium platform, and so the Selenium 1 platform that by integrating Perseus allows one of the tier 1 providers, thank you Ben, and Susan, and allows us essentially to deploy at scale all over the planet. Other encoding vendors, there are 3 other encoder vendors that are integrating Perseus. This will be the first implementation available, but there are many others that are following suit very quickly. So the interesting thing is we take the last 6 months, we had over 1 million people and users receiving Perseus streams, and we plan with this and with what we're doing, this number to grow by orders of magnitude in the next months. And with this, I will leave it from
like comprehensible computer, yeah, it's very good. And I just want to wrap it up. I mean, if you have questions, absolutely, we're here ready to answer them publicly or privately. I mean, it's been quite an amazing journey. It's been 2 years. It's been 2 years in which the industry has changed a lot. The compression market has changed a lot. And I think it's important to highlight as well how much can be done with like a software-centric approach in terms of improving the way we deliver video. So all in all, I think plenty of exciting things to come, and more news hopefully soon. But in the meantime, I'm happy to take any questions. Yeah.